Hello, let's continue. All right, exact same example equation as the previous one. I'm going to show you two more techniques. The main difference is when I use the definition of the logarithm. So in this one, I'm going to use it at the beginning in order to turn it into a logarithmic equation and solve for x. Alrighty, so I'm going to use the exponential on the left as my base exponential. So base 3, I'll have base 3 in my logarithm, and then the exponent is in the circle, and the 2x is in the triangle and becomes the argument like that. Similar to the previous technique, I have the exponent law to move the x in front of the logarithm. I have x's on both sides of the equal sign. Again, maybe consider how many negatives and minuses you end up with. Move it left or right. I'm going to move the x on the left, to the left, to the left, and on the right to the left, like that. Factor the x out, and then divide by that parentheses. Looks different than the previous example, but if you do double check it, you'll see that it is a correct answer like that. The next one, I'm going to use the definition at the end. So to get to that point, I am going to use exponent laws. So if you know them, this is a pretty good technique. If you don't know them, then you got to learn something. So whichever way you want to learn. Again, this is the third technique for solving exponentials. Maybe practice all three a couple of times so you're kind of familiar, and then maybe make a judgment call. You like one better than the other one. Like that. And again, if you learn them, maybe you can use one of them as a double checking technique instead of the plug in the calculator like that. Okay, so the exponent rules, when you have an x plus 1 in your exponent, you can separate it into two bases where each of those numbers is the exponent. And this is one of the rules. If that were a -1, there's a different rule for it. So make sure you know all of those rules like that. I need to get the x's together. So I'm going to divide both sides by the 3x. Another exponent rule says that we've got a fraction like that on the right, and both of the numerator and denominator have the same exponent. I can just make a single fraction with the same exponent. And now I have our standard exponential equation, base to a power equals something. I can use the definition to rearrange that into a logarithm. Again, looks different than the other answers, but if you double check, type it in, you'll see that these are all three same answers to the exact same equation like that.